Now we're going to talk about cams, and in the PowerPoint slide, down in the notes field at the bottom of the slide, I've given you a URL for a website that has some animations of cams and other stuff. So let's look at that before we look at our slides. What you will see is that the whole purpose of a cam is to make this follower go up and down. That's really what this is about, and the cam is just the lumpy thing that makes that happen. And you'll notice that the different shaped lumps in the cam affect the motion and the timing of that follower as it goes up and down. So here's a simpler one, this one in the middle. And what I'd like to point out here, as well as the one above, is that when the cam is in a circular shape, the outside of the cam is a circular shape. Let's see if I can enlarge that a little bit. Notice that the follower does not go up and down at all when the part of the cam comes around that is circular. That's a thing called dwell, which means it's not moving up or down. Here's another cam, and this cam has two different circular segments, a small one and a big one. And what you'll notice again is that when the cam rotates around to that semicircular segment, the follower doesn't go up or down, it dwells. It just stays in its particular height. And we'll learn how to make a graph of that so that we could lay out a cam. But first, let's just get the general idea of cams. So now I'm going to expand this PowerPoint slide. And like with some other kinds of mechanisms, the purpose of a cam is to convert rotary motion from the cam circling around into linear motion, the follower going up and down. And timing of the follower is the main element of this whole mechanism. What we are interested in is the speed and the duration of the up and down movements of the follower. So that's what this is all about. How do we do that? We will make a graph of that timing. That's called a displacement diagram, and we'll look at that in the next set of slides. For now, we'll just sort of get an overview. If you remember when we talked about linkages, we looked at a crank and slider, and here's one turned up vertically. You might notice that the motion of a crank and follower is really similar to the motion of a crank and slider. Okay, it's a different shape, but it's the same sort of thing. The cam is like a crank turning around, and the follower is akin to a slider in its linear motion. Well, we see these all over the place. One common place is in an automobile engine, where we have a thing called a crankshaft, and it's got, or a camshaft, and it's got cams on it. Here's some cams up here, and here's some cams down here. In this assembly of things, the cam is the thing that goes around. It rotates, and it's always got high places and low places. The follower is the thing that goes up and down. And displacement is how far the follower goes up and down. So if you want this thing to rise and fall a total distance of 2 inches, then you could say the displacement is 2 inches. And so this is a weird one. This is an almost circular cam rotating around the shaft, but as the high point comes up, the follower goes up. And then as the low point comes around, the follower goes down. And the total difference between those heights is the displacement. They're all different shapes of cams, and I debated about showing them to you because it's really interesting how many different configurations you could have. But we're going to just focus on one called a plate cam. and it's called that because it's just a flat plate of some kind of steel with lumps on it, and it spins around. So that's the simple kind, and it's the most common kind. And then the follower goes up and down in a motion that's at right angles to the shaft center line. You don't need to remember that, but it's a way to think about what is a plate cam. Last slide. The follower, there are different kinds of followers as well. You can have a knife edge and different kinds of, it can be offset or inline and blah, blah, blah. The most common type of follower is this thing that's pictured in the upper right corner of the slide. This is a cam follower, and you can buy these in catalogs like, all kinds of manufacturers make them. I think you can get them at McMaster-Carr and probably even at Grainger. What you might want to notice is that inside a cam follower are a bunch of very thin rollers. Those are called needle bearings. So this is a kind of bearing that has needle bearings in it. Well, what that means for you as a designer is that you can use cam followers for situations other than cams. And if you wander around through mills and manufacturing shops around Lane County, as I like to do, just keep your eyes out. You will notice that there are cam followers in place out there, various places where somebody needs a smooth functioning roller. Like if you have a guard that's covering some machine or some conveyor, and you want to be able to slide that guard back and forth, you could put cam followers on the bottom edges of that guard and it will slide smoothly. So that's a cool double use for these. In the next set of slides, we'll go on and look at how to figure out the timing and the displacement.